Welcome to The Explainer. Today, we're cracking open the blueprint for NVIDIA's next massive leap. We are looking directly at their 2026 master blueprint, which details a fascinating, frankly aggressive pivot. They are moving artificial intelligence out of the purely digital realm and bringing it directly into the physical world. So let's dive right into this engineering strategy and see exactly how they're planning to build the future. You know, for years now, we've all been completely obsessed with chatbots, large language models, generating cool pixels on a screen. But we have to ask, what actually happens when AI jumps from pixels to atoms? The reality is the ultimate bottleneck for artificial intelligence isn't just about writing better code anymore. It's about the friction of real-world physics. I mean, you can simulate a robot moving perfectly on a computer, but gravity, friction, unpredictable environments, the real world is just a completely different beast. To solve this massive roadblock, NVIDIA is aggressively pivoting to what they call physical AI. We're talking about the actual embodiment of AI in systems that perceive, reason, and act in the physical world. Instead of just generating text on a flat 2D screen, this intelligence gets embodied in physical, moving machines. Think autonomous factory arms or robotic workers that have to safely navigate around humans on a super busy assembly line. Now, to build this physical future, NVIDIA knew they couldn't just sit around in Silicon Valley. They had to pack up and head to South Korea. Why? Well, it comes down to one absolutely staggering number: 1,012. That represents 1,012 robots for every 10,000 human employees in the country. That is a level of industrial robotic density you simply cannot find anywhere else on the planet. It makes it the absolute perfect real-world laboratory for physical AI. Let's look at the core architecture of this strategy, the three-computer blueprint, and how they are engineering the physical world. So the big question is, how do you actually bridge that massive gap between virtual training and physical reality? NVIDIA's answer is a really elegant modular workflow that they call their three-computer solution. It starts off in step 1 with the cloud, moves right into step 2 for digital twin simulation, and then ends in step 3, literally right inside the physical robot's onboard brain. Let's break down each of these three computers to understand how they talk to each other. It all kicks off with Computer 1, the AI factory. This is where the heavy lifting happens, using massive cloud-based clusters of Blackwell GPUs, which are part of their huge APAC 2025 commitment. Inside this factory, NVIDIA is training the heavy-duty foundation models. Think of these as the fundamental underlying brains that allow these systems to learn and adapt. For example, you've got Groot, which is a foundation model specifically designed to control humanoid movements, while Cosmos is over there handling incredibly complex world simulation. Which brings us to Computer 2, the NVIDIA Omniverse. Think of this high-fidelity digital twin simulation layer as a sort of digital womb, where these robots are essentially born. Before a multi-million-dollar piece of hardware ever takes a single step in a real factory, it's trained and safety tested here, using incredibly diverse synthetic data. NVIDIA uses a whole suite of modular workflows, like Cosmos Curator for data processing and Cosmos Evaluator to verify physical accuracy. And honestly, here's why this matters so much. Breaking a virtual robot in a simulation costs absolutely nothing. But a mistake on a real factory floor, that costs millions. And finally, all of that algorithm flows right down into Computer 3, NVIDIA Jetson Thor. This is the edge execution phase, meaning the actual computing happens right there on the physical device itself, rather than way off in a distant server. Jetson Thor is the literal onboard brain sitting right inside the robot. Because of the massive training it got in the AI factory and the intense safety testing it went through in the Omniverse, this microchip can perceive and act instantly in the real world, without constantly waiting around for a logging internet signal from the cloud. Let's shift gears to South Korea's hardware flywheel, moving from silicon to smart factories. You see, to pull this master blueprint off, NVIDIA needs serious partners. Medison Hwang, their senior director of product, was actually in South Korea in 2026 to cement these massive alliances. Just look at the integrations they've built. You have Samsung and SK Hynix working on next-generation high-bandwidth memory. Those are the super-fast memory chips required to process insane AI workloads. Then you have Hyundai and LG handling SDVs, or software-defined vehicles, and smart appliances. NVIDIA is no longer just selling chips transactionally. They are literally embedding their software stack directly into the operating systems of Korean machinery. To really grasp how fast this is moving, take a look at Daegu Robotics. Thanks to this deep technical code development and baking in NVIDIA's Omniverse and Agentic OS, Daegu's roadmap is drastically accelerated. They formed their strategic alliance in 2026, and they plan to debut intelligent robot solutions by 2027. And get this, by 2028, this partnership is pointing straight toward the launch of a fully functional industrial humanoid. 2028! I mean, that sci-fi reality is quite literally just around the corner. This shift perfectly illustrates a massive macro transition that's happening right now. We are moving from the old paradigm to the new paradigm. The old way was just purely transactional hardware supply, right? NVIDIA makes a GPU, a company buys it, end of story. The new paradigm is all about deep technical co-development and agentic manufacturing. In this new world, compute itself actually becomes the primary data source. The machines aren't just following rigid lines of code anymore. They are active agents, learning and adapting in real time right there on the factory floor. Let's unpack the AI bottleneck and the craftsmanship principle, focusing specifically on the dynamic between humans and hardware. Right now, the immediate bottleneck to this entire physical AI future is actually hardware scaling itself. NVIDIA has openly acknowledged that in this era, compute is data. In the past, about 65% of their production costs were tied to Asian suppliers. But today, that number has skyrocketed to 90%. Hardware manufacturing, not just software programming, is now the critical path for AI scaling. By marrying Korea's unparalleled high-density manufacturing data with NVIDIA's proprietary simulation stack, they have created this incredible competitive advantage. They call it a hardware-software flywheel moat. Think about it. The more physical data the robots generate in Korea, the better NVIDIA's software gets. The better the software gets, the better the physical robots perform. Why is this such a big deal? Because this closed-loop ecosystem makes NVIDIA virtually untouchable. Software-only rivals literally cannot replicate this because they completely lack access to that sheer physical industrial density. But what about us? Where does the human element fit into all this? Well, back on April 28, 2026, NVIDIA executive Medison Hwang delivered this landmark lecture to over 1,000 students at Seoul National University. She talked about her own career, going from the luxury goods giant LVMH all the way to NVIDIA, framing it as a masterclass in constant reinvention. And she delivered this incredibly powerful thought. AI is a companion. It cannot replace the craftsmanship required to solve real-world problems. She argued that while AI might totally replace repetitive digital coding, it absolutely still needs human oversight to handle the wildly unpredictable physical world. The crucial takeaway she left the students with is what NVIDIA calls the craftsmanship principle. This is all about mastering the intersection between sensors, silicon, and human problem solving. NVIDIA actually identifies this exact principle, this absolute obsession with detail and physical realities, as the most critical human skill for the leaders who will be managing these complex physical AI systems in the 2028 humanoid era and beyond. And NVIDIA is definitely putting their money where their mouth is to ensure this human hardware synergy actually works. They've committed over 260,000 Blackwell GPUs to their Korean partners as part of the APEC 2025 deal. This massive infrastructure investment floods the zone with the compute needed to spin that flywheel faster and faster. And why is that important to us? Because that sheer horsepower is exactly what accelerates the timeline we talked about earlier, turning those 2028 humanoid predictions from a whiteboard sketch into actual reality. Which leaves us with a pretty profound question to close out the explainer today. As this unbeatable hardware-software flywheel spins up in South Korea, global investors and tech rivals are staring at a massive wall. If you don't have the high-density smart factories to train the AI on physical atoms, how do you possibly compete in the physical AI era? It really seems like the future of artificial intelligence isn't just about who writes the best code anymore. It's about who builds the smartest factories. Thanks so much for joining me today, and I'll leave you to ponder that.